Welcome back to another Math Matters. Today we're going to look at an introduction to matrices. Each one of these three is called a matrix. By itself it's a matrix, plural is matrices. So first I want to just kind of go through some terms and do a little bit of introduction as to how they are. So we can first off have matrices, give them a letter, like this is the A matrix, this is a B matrix, this is a C matrix. It's a way in which we can identify them. When you get to where you're using your calculator, the Texas Instrument calculator, you're going to want to have these labels in there so you know which matrix is which. Now the other thing is matrices have rows and they have columns. So each one of these is like a data input in the row and by the columns, and they're referred to as entries. This matrix right here is called a 2, meaning 2 rows, 2 by 3, 3 columns. And you kind of write it like this. You have a 2 by 3. Okay? This one is referred to actually as a square matrix because it is square in the way in which it looks. Square matrices will always have the same number of rows as they do columns. So in this case, this one is referred to as a 2 by 2 matrix. It has 2 rows and then 2 columns. Rows come first, columns come second. Then finally C, matrix C, is what is called a 3 by 4, and we're going to use a lot of 3 by 4s as we use matrices to help us solve algebraic systems of equations. So this one has 3 rows and 4 columns. So we can have different kinds of matrices, and we refer to them by their rows and then by their columns. There are many uses for matrices, especially in higher math, in sciences and things like that. Even when I was taking math, after I took Calculus 3, there actually was an entire semester course that was just on matrices. But what we're going to do is we're just doing an introduction, so we're not going to get into all the things that you can do with matrices. But one of the things that we can do is systems of equations, which we've been kind of working on manually. Well, matrices can help us solve systems of equations. Now, the first thing we need to come up with is the coefficient matrix. And what we're looking at is, now I've got 3 algebraic equations here, and we want to solve the 3 of them to find what x, y, and z, if any, would make all of these true. So that's why it's called a system of equations, because we're looking for an ordered triplet, and it would be the x, the y, and the z. So the thing that we need to start out with matrices is called this coefficient matrix. Well, if you remember, each one of these terms have a coefficient. It's the number that would be kind of like out in front, like right here, this one, 2. 2 is the coefficient of x for this equation. So we need to list in our matrix all the coefficients that are here. So just one of the things I'll tell you with matrices, take your time and make sure you do it right the first time, because these do take a little while to work through. So coefficient of x in this first equation is 1, even though there's nothing there. Remember, 1 times x is the same as x. We wouldn't put a 0 there because 0 times x would be nothing. It would be gone. So my coefficient here is 1. I want to put that in the first row, the first column. So I'm going to do this over here. I'm going to start my coefficient matrix, and it's just simply 1. It's this coefficient. Now this one, keep in mind the negative sign, because the negative goes with the coefficient. So this one, it would be a 1, but the negative or the subtraction sign makes it -1. So my next one in row 1, column number 2 now, is -1. Z now plus z plus 1z, so the coefficient of z is just 1. This goes in row 1, column number 3. We'll get to these in just a minute because we're just working coefficients, okay? So we want to fill in this matrix with just the coefficients. Go down to the second row now. Down here, column number 1, the coefficient of this x right here is 2. So we'll put in a 2. Coefficient of y is 3. Row 2, column 2. Coefficient of this, there's no z. Well, this is where we have the 0, because 0 times z is 0, because 0 times anything is 0. That's why it's not even here. So we want to put in a 0 as our coefficient for this third term in the second row. Now let's go down to the third row. Third row starts out with a 1, 1 times x. Then we have 2 times y, a 2. And then we have 2 times z. Okay? And then if I were to close off this matrix right now, then I would have what is called the coefficient matrix. But in order to solve a system of equations, we also got to include these guys, because all of this is equal to these over here. And quite often what they do is they'll put like kind of a dotted line right here, just to sort of represent, okay, there's the equal sign, if you will. And then we're going to do what's called a augmented matrix, and that's when we put in what all these equations are equal to. And literally it's just the number again. So here we've got -6, and right here we have 17, and then in the third row we have 7. Now we can kind of close off the matrix just like that. And what we ended up with is this is an augmented matrix. That's what it's called. It is a 3 by 4. There are 3 rows and there's 4 columns going across. We're going to use this 3 by 4 matrix to help us solve systems of equations that involve 3 variables. Now we want to see how we can manipulate basically matrices so that we can eventually solve them. There is basically 3 operations that you can do with matrices where you can manipulate them and still have what is called an equivalent matrix. So I want to start out with the matrix that we ended up with. This is our augmented matrix, and one of the first things that I can do is I can interchange the rows. And if you think about it, it doesn't matter which equation we put on top and which equation we put on the bottom, we still have the 3 equations. Well, that's all we're doing. We want to be able to manipulate this matrix so that we can kind of get it in an order to solve it, which we'll get into in the next video. But we got to get through these operations first. So interchanging rows, here's one of the ways that we kind of indicate what we want to do. Let's say for some reason I want to change the third row with the second row. I just want to change the order in which I write them down. It doesn't make a difference. It's still going to be the same equations. So here's how we kind of show it. We show this matrix, and we're going to take it and we're going to interchange 2 rows. We can put an arrow in here kind of showing that we're going from this one to this one. And what we're going to do is we're going to interchange row 2 with row 3. Okay, so we're just kind of going to interchange the 2 rows, and we kind of show that with the arrow. So if we're interchanging row 2 and row 3, then we're not even touching row 1. So let's just put row 1 right into the new matrix that we're developing. We just transfer it over. 1, -1, 1, and -6. Okay. Now here's where we want to switch these. So now I want to take row 3 and put it in place of row 2. So here we go. We're just going to transfer it over. 1, 2, 2, and 7. And now take row 2 and we're going to stick it down here in row 3. 2, 3, 0, and 17. And then we'll just kind of put in the little dotted line here. And now we've got an equivalent augmented matrix. this matrix is exactly the same value-wise as this one over here. These two, I could put literally an equal sign right in here. These are equivalent matrices. The next operation that we can do to manipulate or change our matrix, and here's where we left off. Now we're going to take and we can multiply a row by a non-zero constant. So if you think about this, we did this when we were doing equations where if we had fractions in the equation, you could multiply both sides of the equation by the least common denominator and eliminate the fractions. If we had decimals in the equation, quite often we multiplied by 10 or 100 and we were able to eliminate the decimals. Well, this is just kind of another way of looking at, okay, we're doing exactly the same thing. As long as we multiply what's on the left side of the equal sign by the same amount as to what it's equal to, then the equation remains balanced. That's what this is doing. We're just simply multiplying the row by a non-zero, can't do zero, non-zero constant. So what we want to do in this case is I would like to multiply row 2, this row right here, by -2. Okay? So how do I show that? We're going to transform, manipulate this matrix to this one, and what we're going to do is we're going to multiply row 2 by -2. Okay? So, excuse me, row 1 and row 3 we're not going to touch. We're going to just leave them the way they are. So I'm going to move them real quick into the new matrix. So we've got 1, -1, 1, -6, and down here we got 2, 3, 0, and 17. So we're not even going to touch those. They're just going to kind of stay there because we're not working on those. We're only working on just this row right here, and we're going to multiply it by -2 and then write the answers over here. So we're going to take this second row, this equation right here, multiply by -2. 1 times -2 is -2. 2 times -2 is -4. 2 times -2, once again, is -4. And then 7 times -2 is -14. So what we did is we performed an operation just on row 2 of multiplying it by -2. Now we have a new equivalent augmented matrix to this one. So they both are equal. Both of them are augmented matrices. Now the third and last operation that we can perform on matrices, these are the only 3 that we need to solve a system of equations. It's just these 3. On this one, we're going to add a row to a row and then replace one of those 2 rows. So we can take and add like row 2 to row 3, and then I want to replace or take the answer and replace it for row 2. That's what I want to end up doing so that I can get things heading the way I want it, which we'll talk about on the next one. So again, row 1 and row 3, we're not going to change those. We're just after row 2 only. Now how do I write this? I want to take row 2 and add it to row 3, and then we're going to replace row 2 with the answer that we get. So I'm going to just transfer over row 1. So here we go. 1, -1, 1, -6. And row 3, we're not going to change that one either. So we'll just move that one over. 2, 3, 0, 17. Now, here's where the work comes in. This is where we're kind of manipulating the 2 matrices now. So, row 2 added to row 3 put in our answer over here, okay? So here we go, row 2, -2, plus row 3, add 2, -2 plus 2 equals 0. The next column, -4 plus row 3, 3, -4 plus 3 is -1. The third column, -4 plus 0 is -4. And then don't forget these guys. We got to do these too. You got to do all the way across. -14 plus 17. -14 plus 17 is a positive 3. And that basically is the 3 different operations that we can do to manipulate a matrix. All of the matrices that we ended up with are called equivalent. This is equal to this one. Both of them would give us the same answers. They are exactly the same. They're a little different as far as the numbers goes, but that's sort of like, if you can imagine, if I were to have 3/4 is equal to 6/8, both of those fractions are the same value. 3/4, if you want to put it in decimal, it's 0.75. 6/8, take 6 divided by 8, you'll find out it's 0.75. They both have the same value, they just kind of have different names. Well, both of these matrices are exactly equivalent, it's just that their names have changed a little bit, but they're equal. So basically, here's the 3 things that we can do with manipulating a matrix. First, we can exchange rows, okay? But it's the entire row. Replace row 1 with row 2, replace row 2 with row 3. Doesn't matter. We can replace rows, change them however we want. Secondly, we can multiply any row all the way across by a non-zero constant. We cannot do 0, but a non-zero constant. And then the third thing we can do is add a row to a row and then replace one of the 2 that we were using, and that is the third operation. Now, quite often we do combine the second and the third. Sometimes we will multiply and add and replace all at one time, but we'll get to that in the next video. But right now I'm after what can we do to manipulate matrices. Those are the only 3 things that we can do. And if you think about in the previous lessons that we were doing, we did similar things when we were adding or using addition to solve a system of equation. Quite often we multiplied the equation, then added the 2 equations together to get one of the variables to drop out. Doing the same thing here in matrices, it's just we don't have all the x, y's, and z's. Now there's one more thing that we need to kind of get through in order to use a matrices to be able to solve our matrices. And that is, we need to get a matrix into what they call is upper triangular form. Okay, so first I want to start out with just a very generic matrix, and this again is something that if you go to use your calculator, it uses the same type of input as what I'm going to do right now. I'm going to use the letter A to represent any number. So this is where before we had 1, -1, 3 and all that, but I don't want to get confused with numbers, so I'm just going to use the lowercase letter a to kind of represent the numbers in a generic matrix, if you will. So I'm going to start out with A, and then 1, 1, because that represents row 1 and column 1. And then right here we would have A, row 1, column 2. And these you're going to need to know again for your calculator, because that's how we're going to put numbers into the calculator. The last one here is A1, 3. And then over here, even though it's across the dotted line, it still is A1, 4. Okay? And then the second row, A2, 1, A2, 2, and A2, 3. Row always comes first, and then the column comes next. So then finally the third row, we're going to just do a 3 by 4 matrix. A3, 1, A3, 2, A3, 3, and A3, 4. Okay? Now keep in mind, in a matrix, when we go to solve these are all going to be numbers. They're not going to be A's. It's just a way that I can kind of talk to where they're going to be at. Now, the upper triangular form, the first thing we want to do, we want to use those three manipulation steps, those three operations that we can do to a matrix to get A21, A31, and A32 to all be zeros. So we need to manipulate these, and we need to end up with A11, A12, A13, A14. Basically, nothing happens with the first row. Now, down here, we want this one right here to end up being a 0. So we need to add, subtract, or multiply, or divide. I didn't think about that when I was talking about multiplying. You can also divide because division is multiplying by the reciprocal. But somehow we got to get this to be 0. And I'll show you that more when we get into solving one. This is still A22, A23, A24. And then down here now we want A31 to end up being a 0 again. Manipulate it, add, multiply, whatever we need to do. A32 we also want to be a 0. And A33 and A34 kind of look like that. Now, if you kind of can look at this in geometric shape, if you will, this does kind of form a triangle right here. And it's not the upper one, but it's actually the lower one. But as we continue to manipulate this matrix, we want to end up with kind of the numbers that are left where they sort of form a triangle on this side, and we're going to have all zeros on this side. So the next step that we want to do, I'm going to pause the video just for a second here, and then we'll come back. We want to get all of these right here to be 1s. So let's pause for just a second, and we'll be right back. All right, now we've got the zeros down here in the triangle. In order to get that upper triangular form that we want to have, then we need to go to the next step now. Using only those three operations we talked about earlier, moving rows and adding and multiplying and all that, we want to get this diagonal right here to be all 1s. So in other words, we want A11 to be a 1. Actually, the number 1, positive number 1 even. A22, we need to manipulate it till this is a 1. And then finally, A33, we want this to be a 1 as well. And now, kind of, if you look, we've got, these are, remember, these all represent numbers, but here's our upper triangle, upper triangular form where all the numbers fall into this triangle. And if you even want to look at it, here's the triangle of all the zeros. So this is kind of what we're trying to get to by using those methods of manipulating the matrix. And from this, then, we will be able to solve that system of equations. This is our goal. I really look at doing matrices as kind of like a mystery game, if you will. How do I get from my first matrix to this so that I can know what are the ordered triplets that would make each of those three equations true?